Hello children, let us start 10th class polynomials. Before going to do that, let us have a small discussion about the problem. Better safe than sorry. What do you mean by this, children? See, you might have faced this problem. Sometimes your parents or your teachers will ask you to do something with a great hope that you will definitely successfully do it. But because you are not interested in doing it, you may not put your heart and soul into it, and the work may not be efficient. That will sometimes create certain problems. Then what you need to do, you have to go to them and say, I'm sorry, I could not do it. Give me once again, I'll do it. Why to do that, children? One thing you trust or you believe that if anybody asks you to do something means they have a lot of trust upon you. They know that you will do it perfectly well. That is why they have given. Then what should be your duty? You have to plan for it. You have to execute it in such a way that there won't be any mistake and a perfect solution will be available to it. If you are able to do that, definitely your scope of learning will increase. Your future will become better. Let us come back to the studies. Now we are going to talk about graphical representation of quadratic polynomials. In the previous class, I have taught you about graphical representation of linear polynomial, where I said that linear polynomial is a polynomial where you are going to get a straight line. Straight line may pass to the origin or it may not pass to the origin. I have explained you how the ordered pairs have to be taken and keep it in the graph. Now we are going to talk about quadratic polynomial. What is quadratic polynomial, children? Which is in the form of ax square. General form of quadratic polynomial is ax square plus bx plus c is equal to 0. This is quadratic equation actually. Quadratic polynomial equal to 0 will not be there. This you can write ax square plus bx plus c. Maybe plus or maybe minus. Anything means 1 with x square, 1 coefficient with x and 1 constant term. So here in this problem, you have got y is equal to x square minus 3x minus 4. This you need to represent in the graph. So before going to do that, first you have to prepare a table like this, children. The table should contain first x value. Better you take x values as 7, 0, minus 1, minus 2, minus 3, 1, 2, 3. And the first value is x square. That means what? Each one you have to square it. Minus 3 whole square means what, children? Minus 3 into minus 3, minus into minus plus 9. You have done it here. Minus my x square, let us do for all. Minus 2 means minus 2 into minus 2, 4. So I have written it here. Minus 1 into minus 1 is 1. And 1 square, 1, 2 square, 4, 3 square, 9. So you have done x square. Now you have, along with the sign, you have to check, children. So minus 3x. Minus 3x means what, children? With minus 3 into x value. Minus 3 into minus 3 is 9. I have written here. Minus 3 into minus 2 is 6. I have written it here. Minus 3 into minus 3 is 9. I have minus 3 into minus 3 I have already taken. Minus 3 into minus 1 is equal to 3. That I have written here. Minus 3 into 0 is 0. Minus 3 into 1. Minus 3 into 1 is minus 3. Minus 3 into 2. Minus 6. Minus 3 into 3. Minus 9. Now this minus 4 same you have to take. See, these two lines indicate that you should concentrate on this value and this value. Now what you need to do, how will you get y? If you add all this, you will get y. 9 plus 9, 18. 18 minus 4, 14. Plus 4 minus 4 will get cancelled, 6 is left behind. And 3 plus 1, 4, 4 minus 4 is 0. And here you have minus 4. And here minus 7 plus 1 is minus 6. And plus 4 minus 4 will get cancelled, you have got minus 6. Plus 9 minus 9 will get cancelled, minus 4. So I hope you have understood, children. We have got those values under y. So you have to take the ordered pairs as x is equal to this one, minus 3, y is equal to 14. Minus 2, 6. Minus 1, 0. 0, minus 4. 1, minus 6. 2, minus 6. And then here 2 minus 6. 2 minus 6. 3 minus 4. So ordered pairs you have taken. Now after taking ordered pairs, let us keep these ordered pairs in the graph. So when I have taken graph, what did I do, children? I have taken certain scale because the graph paper might not be sufficient according to the values. For the convenience, I have taken scale. What is the scale that I have taken? On x-axis, 1 unit or 1 centimeter. We call it as centimeters, no? So 1 centimeter is equal to 1 unit. And on y-axis, I have taken 1 centimeter as 2 units. See children, 2, 4, 6, 8 like that I have taken. Because within the given space, I need to fix all the numbers. Now let me keep the values. Minus 3 and 14. So in the graph you will be having lines, children. Very easily you can write. This is minus 3 and 14. Somewhere here I will get the point. Then minus 2 and 6. This is minus 2 and 6 is here I will be getting. Next, minus 1 and 0. Minus 1 and 0 is this point only. 0 and minus 4. 0 and minus 4 is this point. 1 minus 6. 1 and minus 6. Somewhere here I will be getting. And 2 and minus 6 also I will be getting here. 3 and minus 4. This is 3 minus 4. Somewhere here I will be getting. But while doing so, I need, see, you are getting the lines like this. If I join, I can join like this, like this, like this, and I am stopping it here. So, how can I extend it? This is possible only by going for checking, children. Earlier also I said, don't join the lines, go for checking. What is this, children? X square minus 3x minus 4 can be written as x square, splitting the middle term. We heard on in 9th class. Splitting the middle term. Minus 3 I want. That means minus 4x plus x. If I write, I am getting minus 3x minus 4. So, x into x minus 4 plus 1 into x minus 4. That means x plus 1 into x minus 4. Means if x plus 1 is equal to 0, then x is equal to minus 1. If x minus 4 is equal to 0, then x is equal to 4. So x is minus 1 means you should have a point on minus 1. You have already got it. At 4 you are not having, but you keep here at 4 and circle it. Afterwards, here minus 1 comma 0. This is one circle you have done. So solutions you have circled, children. Earlier also I told. First you need to go for checking and get the solutions. And then you start joining all the points which you have got it here. Like this. It should go in this way. Like this. And it goes like this. This is the figure you are getting. This is called as parabola. What is it called? We call it as parabola. So you are getting parabola by quadratic equation. So when you are getting parabola, what is the solution? The solution here is x is equal to -1, x is equal to 4. These are the solutions. So you have got the checking, and checking will tell you the exact answer. So I hope you have understood, children, how to keep this parabola in your graph. You can do it very easily in the graph chart. Do it. Now, let me have a small discussion about parabola. This U-shaped curve which you are getting, that is called as parabola. So how are you going to do? What are different types of parabola you are getting? You see. So different cases of parabola. First case 1. In case 1, when you have x-axis and y-axis, parabola goes like this. Wherever the parabola is intersecting x-axis, those are the solutions. So here, two solutions are possible. In this first case, two solutions are possible. In case 2, if you see, sometimes in this graph, suppose you have got, this is y-axis and this is x-axis. The solution might be like this, either this side or that side, even this side. Here, at only one point the parabola is touching x-axis. Therefore, it has got only one solution. So, in case 2, there is a possibility. Whenever, see, quadratic equations when you are solving, sometimes you will be getting two solutions, sometimes you will be getting single solution. The two solutions, whatever equations for which you are getting two solutions, if you represent them in the graph, you are going to get 2 points as the solution. In case, if the quadratic polynomial is having only single solution, then the parabola intersects x-axis at only 1 point. It is like this. And in case 3, in case 3, what is this case 3 says, children? In case, in some cases, the parabola may not touch x-axis and it goes like this. Here what you can say? There are no solutions. What do you mean by this? You will not get any solution for that. It is a complex roots or complex solutions. It's not possible for you to get the solution. We are going to learn further about this even in quadratic equations chapter. We will be learning about what are the complex roots means. The roots which we are not getting the solution for it. That kind of ones means I have done the first one now, whereas I split the middle term. This splitting of middle term sometimes might not be possible. If you cannot split the middle term, you can say that it has no solutions. So how to check it, how to verify, how to identify that it has no solutions, We will be learning in that quadratic equations topic, children. Now, I hope you have understood about the three cases. Solutions 2 means parabola touches the x-axis at 2 points. Solution 1 means parabola touches the x-axis at only 1 point. There are no solutions means parabola will not touch the x-axis at any place. It will be just hanging upon this x-axis. So write down this children. These are cases of parabola. Now children, let us talk about geometric zeros of the polynomial. Geometrical meaning of zeros of cubic polynomial. What is the meaning of cubic polynomial, children? Cubic polynomial means a polynomial which has power 3. See, you have got it here. Y is equal to x cube minus 4x. This is cubic polynomial. Actually, in your textbook, you don't have any this kind of drawing the polynomials in the graph, but only graph will be given. You need to find out how many zeros are there in it. So let us have a graph that is given to you here. The one which is given here is, see children, this is a graph of cubic polynomial. In this cubic polynomial graph, you can see at how many places the it is not a parabola but the curve. The curve is intersecting x-axis at 1, 2, 3 points. So we call it as cubic polynomials. All cubic polynomials will intersect x-axis at 3 points. So basing on this, you have got another question also here, children. See, you have got two figures here. Here this is also a curve that is given. So where it is intersecting x-axis? At only 1 point. So the solution is only 1 point. Here if you see, here this is intersecting the graph at 2 points. So it has the two solutions here, children, for this problem. Now you have got, see example 1. Here in this example 1, look at the graphs in the figures given below. Each graph of y is equal to p of x, where p of x is a polynomial. In each of the graphs, find the number of zeros of the given range of x. How many zeros are possible? So let us see the first one, children. Here in the first one, it is intersecting x-axis at only 1 point. This one intersecting at only 1 point. So it has only one solution. Here it is intersecting x-axis at 2 points. So it has got two solutions. And let us see this figure. Here it is intersecting the x-axis at 1. This is 1, 2, 3 points. So the solutions are 3. Okay. Now let us see the next figure that is given. Now you have got these figures, children. Here this is a line. This line is intersecting x-axis at only 1 point. So solution is 1. Here parabola is intersecting x-axis at only 1 point. So it is also having only one solution. And this one, if you see, it is intersecting at x-axis at 1, 2, 3, 4. So these are 4 points. So with this, what we are able to understand, children, whatever the lines, curves that we are getting while solving or while putting the given ordered pairs in the graph, wherever the graph is intersecting, the line is intersecting x-axis, that is the solution. So I hope you have followed this, children.